Okay, section 5.1, day 1. So we're just going to real quickly write these all as fractions. So anytime we have a fraction, we're obviously going to have a, love when that happens. We're going to have a fraction bar for all these problems. Let me go ahead and put that in right away. And remember, at 16 divided by 3, okay, we read top to bottom, 16 divided by 3. 8 divided by 3. The ratio of 8 to 12. Now remember, when we read a book, we read left to right and top to bottom. And that's how we go here. We read left to right, 8 to 12, top to bottom. So the first number we see, 8, goes on top, the bottom number goes on the second number goes on the bottom, 8 to 12. X to Y, first we hit X, then Y. Ratio of 4 to 6, just like that. Okay, a little warm up there. So our goal is to write ratios, solve proportions, and simplify radicals. Ratios, comparison of two numbers, such as boys to girls or girls to boys. Girls to the total number of students in the class. Height compared to age. Map legends. 1 inch equals a mile or something like that. Ratios. There are 3 main ways to write ratios. With a colon separating them, the word to, and as a fraction, which we just did in our warm-up. Be careful with the order of your ratios. The first one mentioned in the problem corresponds to the first one, top of the ratio. That's what we were talking about before. Left to right, top to bottom, as we read. So example 1, a model car is 4 inches long. The actual car is 15 feet long. What is the ratio of the length of the actual car to the model car? Now, you got to be careful here. It's kind of tricky because they gave you this first and then they gave you this second. But look at the actual question. What is the ratio of the length of the real actual car to the model car? So the actual car, this is the first thing we see, which means top. This is second, which is bottom. Now, even though the model car was given to us up here, the measurement was given first, the question asked us to give the actual car to the model. And you can even do this to remind yourself of that. So the length of the actual car is 15 feet. And we want to use our words, feet, because this is only 4 inches. And then we know we're comparing feet to inches. Okay? Now, if this was worded differently, if it said model car to actual car, and then we would flip it upside down, the inverse. Proportions. That's when you have 2 equal ratios. So A over B is equal to C over D. Extended proportions when you have 3 or more that are equal. You were doing this in grade school way back when you took something like 50 over 100. And you said, let's divide it by 2. Oh, that's 25 over 50. Hey, let's divide by 5. That's 5 over 10. Hey, let's divide by 5 again. And say that's 1 over 2. So every time you were doing simplifying fractions way back when, you were just writing extended proportions. Because all of those fractions were equal to each other, all those ratios. So these are all equivalent proportions. Every one of these. Okay? These are all different examples. A over B equals C over D. Well, what's the difference here? Look. A is on top of B and C is on top of D. All we did here was turn them upside down. That's like the model car. If we say inches to feet or feet to inches. And if we say here, A to B, C to D. On the bottom. And then left to right on the top, A to B. And then on the bottom, C to D. And this one, the last one's a little trickier. If we add add C to the top and keep C on the bottom, then we're also going to add D to the top and keep D on the bottom. That is still an equivalent proportion. That one's a little trickier. That one's nice. It helps to like maybe, use real numbers to test it out. Okay, complete each statement using the given proportion. 6x. Well, you get that from doing 6 times x. So that is equal to 5 times y. Okay? Y over x. Well, now we're looking at upside down. So that's going to be 6 over 5. X over 5. Now we're going left to right. So that's going to be y over 6. And x plus y over y is going to be the same as 5, add the denominator, and keep the denominator. 5 plus 6 over 6. Now, to solve a proportion, we can cross multiply. A times D equals B times C. And I encourage you to circle like that. So, for example, here, 7 times x equals 5 times 12. So that's 7x equals 60. X equals, it's a long decimal, but it would round to about 8.6. It's 8.57, so we round up. Okay, this one you got to be careful of whenever you have a binomial, 2 terms together. Because this is going to be 4 times the quantity y plus 3. Don't just write this. That's a common error. It's 4 quantity y plus 3 equals y plus 8. Now we just go back to algebra 1, do some distributing. 4y, don't forget 12, equals y plus 8. Now we're going to subtract y and get 3y. We're going to subtract 12 and get negative 4, 8 minus 12. Then we divide by 3, get y equals negative, 4/3. We're dividing by 3, I just said that. So again here, 3 times 5, we can write it out, or if you want, you can just kind of, when you're doing numbers, you can just go right to writing 15 equals 20 times z. We divide both sides by 20, and we get z equals 15 over 20, which then reduces, divide by 5, 3/4. Don't forget your parentheses, 18n. It doesn't matter which one's left, which one's right. 6, parentheses, n plus 6, parentheses. Now we distribute. 6n plus 36. I'm going to subtract 6n from both sides, which gives me 12n. And now we get 36 divided by 12, which is 3. Example 3. 2 cities are 3.5 inches apart on a map with a scale of 1 inch equals 50 miles. Find the actual distance between the 2 cities. So here you kind of get to decide what you want to do. I'm going to put inches and miles like this. So I always look for my equality statement first and set that up because that's my guide. And then I look at what I have. I have 3.5 inches. So where's that going to go? Up here, because inches is on the top. And this is my unknown. And now, I just have 1 times x is 1x equals 50 times 3.5. So x equals 175, don't forget your words, miles. Which makes sense if you think about it. Every inch is 1 mile. So 1 inch miles. Another inch, which makes 2, would be 100 miles. A third inch would be 150 miles. And then half an inch would be 25. And that's why half 50 is 25, and we get 175. So it really does make sense. You can kind of check that if you want. And that's it.